Hello everyone and welcome to our latest maths lesson where we continue to look at fractions, and we are looking at comparing and ordering fractions as are greater than 1. Remembering the rude rule, whatever you do to the top you do to the bottom, and then I'd just like you to pause the video and have a go at these two questions here. If you end up with an improper fraction, see if you can convert it to a mixed number. And pause the video and have a go at those. Right, let's look at this one first. So remember, when you add fractions, the denominator stays the same. So if I put my equal sign, my denominator stays the same. I'm working in sevenths, I'm still going to be working in sevenths afterwards. You do not do 7 add 7. It's not everything added together. It's just going to be the numerators. So we just have to do 3, add 2, which is 5. If I visualize that, so it's not going to be exactly equal parts because I'm drawing freehand, but I'll give you a vague idea, or a good idea. 2, 3, 4, 5, 6, 7 parts. Okay, so if I've got 3 parts out of my 7 shaded to begin with, and then I add 2 more, I'm going to have 5 parts out of my 7 shaded, so it's going to be 5 sevenths. If you were to add the denominators together, you're going to end up saying it's 5 14ths, which is not correct. So denominators stay the same, numerators add together. Okay, let's look at the next one, which is a little bit different. Because 7 adds 6, remember the denominator stays the same, we're still going to be working in eighths, the denominator stays the same. 7 adds 6 is 13. Hopefully you remember that that is an improper fraction because the top number, the numerator, is bigger than the bottom number, the denominator. So 13 eighths is the answer as an improper fraction. If we want to convert this into a mixed number, if I break it down a bit more, 13 eighths is the same as saying 8 eighths plus 5 eighths. And the reason I've chosen to split it into 8 eighths and something is I know that 8 eighths is worth 1 whole. So that helps me with writing that as a mixed number. So 8 eighths is worth 1 whole. And then we have the 5 eighths. So here is my mixed number. So well done if you got those. Let's move on to another few warm-up questions. So we have 3 questions here. This one is saying 2 ninths equals same as how many 27ths? This one is asking you to compare 7 ninths and 14 eighteenths. Remember, to compare them, you want to make the denominators or the numerators the same. So how could you change those to do that? Remembering the rude rule, whatever you do to the top, you do to the bottom. And we have something sevenths is bigger than 1, and then we have 2 19ths. Can you compare that to 1 8th? Okay, remembering you need to make either the numerators or the denominators the same to be able to compare it. So pause the video and have a go at those questions. Okay, let's have a look at the first one. So 2 ninths equals how many 27ths? So to get from 9 to 27, 9 times 3 is 27. So to work out the number at the top, you do 2 times 3. So 2 times 3, alongside it's 6 sevenths. Let me just put those back in. So 9 times 3 and then 2 times 3. We're using the rude rule, which is whatever you do to the top, you do to the bottom, or whatever you do to the bottom, you do to the top. Okay, here we're comparing 7 ninths to 14 eighteenths. I want to know which one's bigger, which one's smaller, or if they're equal. So what I'm going to do is I'm going to multiply this side by 2 to make it into eighteenths. So 9 times 2 is 18. Whatever you do to the bottom, you do to the top. 7 times 2 is 14. So what we're actually comparing are fractions that are worth 14/18 and 14/18. So that is equal. Okay, let's look at the next one. So 7ths, not 7/7, it looks like a 7. Something 7ths is bigger than 1. We know that 7/7 equals 1. So basically all we need to do is choose a digit that's bigger than 7 to go on that side to make it bigger. So we could have 8, we could have 9, we could have 10, we could have any number that's bigger than 7. The last one, we have 2/19 and 1/8. You can't change the denominator so it equals the other denominator, so we're going to have to work with the numerators here. So what we can do is we can multiply this side by 2, so we make the numerators the same. So let's do it next to it. So 1 times 2 is 2, whatever you do to the top, and you do to the bottom. 8 times 2 is 16. And remember, when the numerators are the same, if the number on the bottom is bigger, you're going to have a smaller fraction, because that's 2 divided into 19, 2 divided into 16. This side is bigger because we have 2 divided by 16, which is bigger than 2 divided by 19. Okay, let's move on to today's learning. So we want to compare these fractions, so which one is bigger, which one is smaller. So we have 11/7 and 9/7. Which one do you think? When the denominators are the same, the greater the numerator, the greater the fraction, which means 11/7 is greater 9/7. Okay, now we're comparing 7/5 to 13/10. 7/5, 13/10. We can see if we line them up that 7/5 is greater than 13/10. If you struggle with that visualizing side of things, you can make the denominators the same. So 5, what do you do to that to make it equal 10? You times it by 2. So that's 10, whatever you do to the top, you do to the bottom, whatever you do to the bottom, you do to the top. So 7 times 2 is 14. So 14/10, which is what this is worth, has to be bigger than 13/10. So there's different ways of showing that. When the denominators are the same, the greater the numerator, the greater the fraction. Always going to write over it, isn't it? Here we go, 14/10. Keep writing exactly the same place. Okay, so this is where we pause the video and you have a go at comparing these. Remember, to compare them, you need to make either the denominators or the numerators the same. So what can you do to those denominators or numerators to make them the same? And if we just quickly look at the first one, you can't change 16 to make it equal 29 by timesing or dividing. However, you can change 12 to make it equal 24 by timesing. So have a go at those. Pause the video, have a go at them. Okay, let's go through these. So we have 29/24 compared to 16/12. 16/12, if you times the top and the bottom by 2, rude rule, you're going to work out that that is equivalent, equal to, or of the same value to 32/24, which is bigger than that. So 16/12 is bigger. The next one, we have 10/7. What do you multiply 7 by to get 21? You multiply it by 3. Whatever you do to the bottom, you do to the top. 10 times 3 is 30. So then we compare 30/21 to 26/21. 30 is bigger than 26. The last one, we have 89/44 compared to 6/4. You can't do the numerators, so let's do the denominators. What do you times 4 by to get 44? 4 times 11 is 44. Whatever you do to the bottom, you do to the top. 6 times 11 is 66. So we're comparing the 89 to the 66. 89 is bigger than 66. Also, you could have noticed that 89 is greater than double the denominator. So 44 times 2 would be 88, and it's bigger than 2 wholes. So that would be 2 wholes and 1/44. 6 quarters is only worth 1.5. So that's another way you could do it. I find it easier to convert the denominators to see it, but you might prefer visualizing it and picturing it in your head or working it out in a different way. Okay, this one we have the numerators the same, so 15/13 compared to 15/10. Show those. So 15/10 you can see bigger than 15/13 if you visualize it with your bar models. However, we also know if the numerator is the same, the greater the denominator, the smaller the fraction. And you can see that visualized here. When the numerator is the same, the greater the denominator, the smaller the fraction. Bit of repetition there. Right, now we have 27/24 compared to 9/5. When the numerator is the same, the greater the denominator, the smaller the fraction. So you need to convert the 9/5. So the numerators are the same. So times the top and the bottom by 3, because 9 times 3 is 27. You get 27/15. So 27/15 is bigger than 27/24, because remember, we look at this rule. When the numerators are the same, which they are, the greater the denominator, this one's greater, the smaller the fraction. So we know this is going to be the smallest fraction. So what do you think about this one? How could you make the numerators the same and then compare them and then look at this rule to work out which one's bigger, which one's smaller? Okay, so we can make 4/5 into something that's got an 8 on the top by multiplying by 2. 4 times 2 is 8. Whatever you do to the top, you do to the bottom. 5 times 2 is 10. 8/10. So just remind ourselves, when the numerator is the same, 8, the greater the denominator, so 10 is bigger, the smaller the fraction, so this side must be smaller. Another way of looking at it is, you know that 8/7 is bigger than 1 whole, because 7/7 is 1 whole, whereas 4/5 is smaller than 1 whole. So Rosie and Amir both baked some cakes. They got a little hungry and ate part of a cake. Rosie says, I have 2 3/4 of cake left. Amir says, I have 2 6/7 left. Who has the most cake left? So how can you compare those? So you have 2 3/4 compared to 2 6/7. What's the same about each mixed number? They both have 2 wholes. So we can ignore that because we don't need to compare 2 to 2. So what we're really doing is comparing 3/4 and 6/7. And remember that rule, when the numerators are the same, the greater the denominator, the smaller the fraction. So how can we change one of those so the numerators are the same? What can we do with 3 to make it equal 6? Multiply it by 2. So 3 times 2 is 6. Whatever you do to the top, you do to the bottom. 4 times 2 is 8. So now we're comparing 6/8 to 6/7. When the numerators are the same, 6, 6, the greater the denominator, 8 is bigger than 7, the smaller the fraction. So this side is smaller. So we have the pointy end pointing towards the small one, the open mouth of a crocodile, if you want to think about it that way, pointing towards the bigger one. This is just another way to look at it. So 1/4 is bigger than 1/7. We have 3/4. We have 6/7. You can see that 6/7 is bigger than 1/4. So that's just doing it in the bar model, making sure your holes are the same length and then comparing them. So Amir has the most cake left. So great time to pause, have a go at questions 1 to 4 on the worksheets, and then come back to see the rest. We'll continue and watch the video to the end. Order these fractions in ascending order. Remember, ascending is up and descending is down. So we're going from smallest to biggest. Okay. When the numerator is the same, the greater the denominator, the smaller the fraction. So you can see that you can convert these, so the numerators will be the same. You can't convert the denominators, so they'll all be the same. 17 isn't in the 9s, the 2s, or the 3s. Whereas 20 is in the 5s, the 4s, and the 2s. So you can convert those so they have the same numerator. So 2/3, 2 times 10 is going to be 20. Whatever you do to the top, you do to the bottom, so you get 20/30ths. The next one, 4 times 5 is going to be 20. Whatever you do to the top, you do to the bottom. 9 times 5 is 45. What do you do to 5 to make it equal 20? 5 times 4 is 20. 2 times 4 is 8. The last one is already converted. It doesn't need to be converted, it's already got 20 as a numerator. So here, to remind ourselves once again, when the numerators are the same, which they all are now, 20, 20, 20, 20, the greater the denominator, the smaller the fraction. So which one has the greatest denominator? 17, 8, 45, or 30? So it's 45. Remember, we put the original one in, so 4/9 is going to go in there for being the smallest, rather than what we showed it was worth. The next biggest denominator is going to be 20/30ths, so we had 2/3, that's going to go in next. The next one, 20/17ths or 28ths, so I'm going to go for 20/17ths. Cross that off, because we've used that, as you notice we're crossing it off as we go. And the last one, 28ths, which is worth 5 halves, it's going to go in at the end. Okay, so order these fractions in descending order. I'm not sure why that third's come up. It's supposed to be the thinky sign. So just remember this rule at the bottom: when the numerators are the same, the greater the denominator, the smaller the fraction. So how can you make those numerators all the same? How can you make 5 equals 60, 1 equals 60, 30 equals 60? Or make them all equal 30. 60 you can divide by 2 to equal 30. 32 is in the 2 times table, so you can do that, and then you can multiply these to get up to 30. So 60 divided by 2 is 30. 32 divided by 2 is 16. This one, 1 times 30 is 30. 2 times 30 is 60. 5 times what is 30? 5 times 6. Whatever you do to the top, you do to the bottom. 4 times 6 is 24. So now we can compare them because the numerators are all the same. Remember, we're doing descending, so we need to go from biggest, and we put a B for biggest, to S, which is smallest, biggest to smallest. So how do you get these compared? Let's just remind ourselves of the rule. When the numerators are the same, 30, 30, 30, 30, the greater the denominator, the smaller the fraction. So which one's got the greatest denominator? That one's got the smallest, so we need to look for the biggest denominator. It's going to be this one here, 30/16, which is worth the original one. Remember, we need to put the original ones in. So if you have your worksheets, remember, once you convert it, you still need to put the original one in the answer box. 60/32. It's going to get in. What's the next biggest? Let's cross that one out so we don't accidentally put it in again. So which one is the next biggest? The next smallest. Now 30/19. That's going to go nicely. Cross that out, and then we want the next smallest number out there. So 30/24. So 5/4. It's going to go in there, and then the last one. So we're not going to put in. We converted it to. We're going to put the original in. So 1/2 goes in. Okay, this time order these fractions in ascending order. So smallest to biggest. The rule we're looking at. When the denominators are the same, the greater the numerator, the greater the fraction. So have a think, how can you make those denominators the same? Might be different ways to do it, and then you'll be able to compare it. So how do we make the denominators the same? Okay. So if we do 4 times 4, we get it into 12, so 16 twelfths. Remember, whatever you do to the top, you do to the bottom. 10 times 2, 20 over 12, because whatever you do to the top, you do to the bottom. You times 6 by 2 to get 12. Now how are we going to do this one? 10 is double 5. So 10 fifths is worth 2. So 11 fifths is worth more than 2. So those ones are all going to be smaller. So we're going to put that one straight in, because we know that that is worth more than 2 wholes, because 5 fifths plus 5 fifths plus 1 fifth is 11 fifths. Because we know that's worth more than 2 wholes, we can put that straight in as the biggest, because we know none of these other ones are worth more than 2 wholes, because that would have to be more than 6 thirds, that would have to be more than 24 twelfths, and that would have to be more than 12 sixths. So that one's in. We can ignore that one now. It's done. Right, so how are we going to work out the next one? So when the denominators are the same, the greater the numerator, the greater the fraction. So we're going to put 4 thirds in, because it's got 16 twelfths. 16 is smaller than 19, and that's smaller than 20. So this one, the original 4 thirds, goes in. Which one's the next smallest? So 19 is smaller than 20, so 19 twelfths is going to go next. And then the last one goes in. So remember, we put the original in, which is 10 sixths. Okay, so then have a go at this one. Order these fractions in ascending order, so smallest to biggest. If there are any where you know you can't make the denominators the same, so for example, if you're going for 20ths, can you make 11 equal 20? No, you can't. But what do you notice about this fraction compared to the rest? What do you notice? Okay, we're going to convert these into 40ths. So 7 times 8 is 56, 5 times 8 is 40, so they now have the same denominator. 25 times 2 is going to be 50, and 20 times 2 is 40. These three now have the same denominator. Now let's have a look at this one. 10 elevenths. This is a proper fraction. Remember, a proper fraction is where the numerator is smaller than the denominator, which means it's worth less than 1. These ones, the top is worth more than the bottom. The numerator is bigger than the denominator. So these are all improper fractions. These are all worth more than 1. This has to be the smallest fraction. It's the only one worth less than 1. Okay, and then we can just put the other ones straight in, because remember, we're looking for the smallest number. If we go smallest to biggest, 44 40ths is smaller than 50, and 56 40ths, so that goes in next. Then we've got 50 40ths, which is smaller than 56 40ths, so the original 25 20ths goes in. And the last one, 56 40ths, the biggest one, goes in, so 7 fifths. The original that we had before we converted it goes in. Right, I believe this is the last question we are looking at. So 5 sevenths is smaller than 15 somethings, is smaller than 15 ninths. We need to make something the same, so we're going to make our numerators the same. So the other two are already 15, so what do we do to 5 to make it equal 15? 5 times 3, 15 21ths. So 15 21ths is smaller than 15 watts, is smaller than 15 ninths. So remember, the bigger the denominator, the smaller it's going to be, because it's been divided into more pieces. So we can have anything there between 20 and 10. And the numerator is the same, the greater the denominator, the smaller the fraction. So we could have 11 there. Any integer, any whole number between 10 and 20 fits perfectly in there. Okay, so using that as an example, how can we answer this question? Okay, so if we times it by 4, so we're looking at making the denominators the same here. So 3 sevenths Using the root rule, whatever you do to the top, you do to the bottom, becomes 12/28. Times it by 2, something 28. So this can be any integer between 3 and 11. Is that correct? So we've got 28 here on the bottom, so we know the bigger the numerator, the bigger it's going to be. So 3/7, which is worth 12/28, is bigger than something 28 is bigger than 2/28. So this is asking you, does that work? So 7/28. But we've got to divide it by 2 to get back to the original. 7 divided by 2 is 3.5. None of that. So any even integer between 3 and 11, because you've got to work backwards. So divided by 2 is 6, divided by 2 is 3. So 2/28 is smaller than 3/14, is smaller than 3/7. But when we have one more. So how can we do that one? So pause the video, have a go at that one. How can you compare those? Half of 21 is 10.5. That is 1/2. So it can be any integer between 11 and 17, because that's only worth half. So anything more than half is going to be bigger than that. And half is 10.5, so any integer between 11 21th is going to be more than half the whole, and it can't be above 17 because this one's 18 and we want it to be smaller than that. So let's put anything between 11 and 17 in there. So let's put 12. Okay, so here we have some reasoning questions. So Rosie and Jack each have 3 identical chew bars. Jack divides each of his bars into 4 equal pieces and eats 5 pieces. Rosie divides each of her bars into 2 equal pieces and eats 5 pieces. We've both eaten the same amount because we've eaten 5 pieces each, says Jack. Explain why Jack is not correct. So have a think about that. How can you make that into fractions and compare them? Okay, let's have a look. So Jack, 12 quarters. She has got, it's in halves, 6 halves. He's eaten that many. So 7 quarters remaining. She's eaten that many. Half remaining. Which one's bigger, 7 quarters or a half? You can see that is worth more than a whole. That is not. So you could convert it into quarters to make sure. But we know that 7 quarters is worth more than half. Okay, your activity has been assigned on Teams or Tapestry. Let us know how you get on. Make sure you check it against the answer sheet. Thank you very much for listening.